This video will discuss the solution to question 39. Please consider the DAC circuit in figure 7. The DAC is ideal except for the input offset VOS of the op-amp. About how large may the offset voltage VOS at most be so that the error in the most significant bit is not larger than 50% of VLSB. If Vref is 1 volt, R1 is 1 kilo ohm and RF is 512 ohms, and then 8 possible values are given. Let's first write down the given information. The reference voltage is given to be 1 volt. The resistance R1 is 1 kilo ohm. The resistance RF is 512 ohms. And the caption here tells us that this is a binary DA converter, meaning that every consecutive resistance will have double the resistance of the previous resistor. So R2 will be 2 kilo ohms, R3 will be 4 kilo ohms, and R8 will be 128 kilo ohms. In this question we're going to examine the output for the most significant bit, so the only closed switch will be switch 1, so this connection will exist. All other switches will remain in their current position connected to ground. The final bit of information that has been given to us in the question is that we have a non-ideal voltage offset at the input of the op-amp, meaning that the voltage at the non-inverting input will be VOS. Given that we only use the most significant bit as the input to this DAC circuit, we can redraw this situation as the following. And finally, the potential at this non-inverting input will be VOS, and that is a non-zero offset voltage. With this situation, we can set up a nodal analysis equation at this inverting input. That will give us the following. We can now use this balance to set up an equation for Vout, and that will look like the following. Since the offset voltage is a non-ideality in our circuit and under ideal circumstances VOS should be 0 volts, we can consider these two terms to be error terms. So the absolute sum of these two terms will be the absolute error that is created by this offset voltage. The question statement says that this error may not exceed half the least significant bit voltage. And we found in question 37 that the least significant bit voltage is minus 4 millivolts. If we want the magnitude of this error to not exceed half of that least significant bit voltage, the error should remain smaller than 2 millivolts. If we now solve this inequality for VOS, we will get that VOS needs to remain smaller than 1.32 millivolts.